Hi everyone, this is Zara from Global AI Hub. We have another webinar today from David Talby, who is the CEO of John Snow Labs. So let's welcome David. Hi David, how are you?
Excellent. Glad to be here. Thank you for the invitation.
Thank you so much. So could you give like a brief introduction to the speakers about today's topic and about yourself before we start?
Of course. So I'm a computer scientist. My background, I have a PhD in computer science, an MBA. Worked for Amazon and Microsoft in the past, and then got into natural language processing back in 2012. Late in the decade, I joined John Snow Labs, and I was one of the people who created the Spark NLP library. And what I'd like to help everyone here today is with understanding how you can use some of the completely open source software for your own NLP projects.
All right, that's great. So let's get started with your talk. I wish you the best of luck.
Thank you. Can everybody see the screen, or do you need to share again? Oh, great. Okay, so hello everyone. Happy to be here. Please ask questions in the chat as we go along, and I'll do my best to answer as during the talk. If not, always welcome to ask questions at the end. So we are going to cover three things today. We're going to talk about where the Spark NLP library is now, kind of at the end of 2020. We are going to talk about what state-of-the-art NLP means at this time, in terms of accuracy, speed, and scale. And then we're going to focus on really the ease of use aspect. And we're going to talk about the NLU library, which enables you to take advantage of really everything we'll discuss basically in one line of Python code. So let's begin. So Spark NLP is an open source library for natural language processing. By the way, everything, all the code, all the libraries that I'm going to show you today are not just open source, they're also the Apache 2.0 licensed, meaning you're welcome to use them any way you like, both personally and commercially. You can take them, you can sell them and charge money for them. You can change them however you want. There are no restrictions whatsoever. So Spark NLP was designed to deliver state-of-the-art NLP to the open source community in terms of accuracy, speed, and scale. It's a set of open source libraries for Python, Java, and Scala with complete APIs for all three languages. And beyond the code itself, it's also a growing set of pre-trained models and pipelines, over 300 in total. In 2020, Spark NLP started the year already being the most popular NLP library in the enterprise. But as you can see, it grew significantly during the year. And right now, we're standing at just over 90,000 downloads per week. And this is on PyPy alone. So we're not counting Conda, and we're not counting the entire Java and Scala ecosystem. So we're not counting SBT and Maven and Spark packages. This is just PyPy. So Spark NLP kind of became recognized as the most widely used NLP library in the enterprise in early 2019 with the large O'Reilly AI adoption in the enterprise survey that they do every year with practitioners from around the world. And there it was, I think it was twice as popular as kind of the next NLP library on the list. And there were several other kind of surveys and industry outcomes in 2019 to say basically the same thing. Within 2020, the most recent large survey we have is the first NLP industry survey by Gradient Flow, which is by the way, I do recommend, if you're interested in natural language processing, I recommend downloading and reading the whole report. One of the questions was about which libraries do you actually use, and once again, Spark NLP was recognized as the most widely used library kind of by practitioners. So we're not as strong in the research space, but when people want to put systems into production and use them in the industry setting, mostly they turn to Spark NLP to get the job done. Spark NLP itself has grown rapidly in terms of what it can do. We've been releasing software every 2 weeks, at least, for the past 3 years. So the library has progressed quickly in terms of functionality. It's a full end-to-end library. Really, if you use it, you don't need to use any other library to complement it. It starts with the basic things like splitting text into sentences, tokenization, stemming, lemmatization, part-of-speech tagging, spell checking, the dependency parsing. And then it continues into more kind of the more advanced tasks, like training your own name and entity recognizers, document classifier, emotion analysis, and so on. It comes built in with more than 90 different transformers, basically all of the ones that have been used to achieve state-of-the-art results, and it has some support for 46 languages. So that's overall in terms of what the library can do. In terms of where it runs, the library has complete API support for Python, Scala, Java, and there's also our bindings. It's been contributed by Dave Kincaid, by the community. It does run on Apache Spark, and it can run on any Spark installation or server or cluster. Of course, it can also run locally. So one common question is that does it require a cluster, require a distributed environment? Absolutely not. Most of the development on Spark NLP is people using Python on their own laptops, and of course you can run it in local mode. But the nice thing is you can scale to a cluster if you need to. You can see here the environments that we test on, and the nice thing now is that because Spark NLP is so widely deployed, whatever your environment is, there are quite a few companies who are already using it in production within that environment. So we solve the initial configuration, security, scaling bugs. We regularly test with Databricks, Cloudera, Azure, AWS, Kubernetes. There are also quite a few deployments on GCP. And we'll talk about the specific hardware optimizations we do for NVIDIA and for Intel. So that's the library overall. If there are any questions, as I said, you're just welcome to type them in the comments as we go, and I'll try to address. Now, let's talk about what state-of-the-art means where we are today. So first of all, state-of-the-art is not a marketing term, it's an academic term. And when you say that a model is, or a result that you publish is a state-of-the-art result, what you're saying is that this is the best possible accuracy by whatever agreed metric you're measuring on public academic benchmark that's reproducible in a peer-reviewed result. And a lot of what we do is we productize research. So we continuously read the papers, we look at conferences. Whenever someone claims to have improved the state of the art, right? So you come say, hey, I have this new transformer, new deep learning architecture, new whatever, and it achieves slightly better accuracy than before on the same benchmarks that everybody uses. We try to reproduce it. If it does reproduce, if it generalizes, we take it on ourselves to give the community the production-grade, trainable, and scalable version of those algorithms. That's what we do. One of the popular tasks you can see here is name entity recognition, and that's one of the areas where we have results. And by the way, we have notebooks for all of these, so it's reproducible. You can run it yourself, as tens of thousands of people have done. And for example, on the CoreNLL 2003 NER, if you actually train it with Spark NLP and you look at the results, basically you're going to get the most accurate results on a production-grade system that's available today. Another common set of tasks is around document classification. Okay, so document classification is kind of given a piece of text, you need to classify it in some way. For example, is this email spam or not spam, right? Is this a paragraph fake news or not fake news? Is this a positive or negative or neutral sentiment? So Spark NLP it comes with a pre-built, pre-trained set of document classifiers, but you can also train your own, right? And for that, there's a set of deep learning algorithms that the library comes with, and a set of sentence embeddings that you can use to train your own models. You can see here an example. One of the pre-trained models is a model that classifies toxic content, right? So you can look at content and say, oh, is this an insult? Is this a threat? Is this an obscenity? Is this a sexually explicit content? So we have a pre-trained model for that. but you can also train your own. One of the nice things about what Spark NLP support is, of course, you can have multi-class. You can train a multi-class model. Okay, so for example, it does not have to be whether sentiment is positive or negative. It can be one of those 7 categories, as in here. It can also be multi-label, meaning you can also train a model where more than one label is correct at the same time. Okay, for example, something can be an insult and a threat at the same time, and we produce some pretty tame examples here. But I'm sure if you go and you try this online, you can try and you can be much more toxic than that if you really want. One of the big popular things that happened in the NLP space in the past 3 years are embeddings and transformers. And with Spark NLP, those come out of the box. So part of the kind of the model ecosystem is providing those to you. And as you can see, you have quite a selection. So you have all of the kind of what you'd expect. You have BERT models, BERT in different sizes, BioBERT, universal sentence embedding, language agnostic sentence embedding, Albert, ExcelNet, Elmo, and a few others. You have multiple versions of them in terms of the dimensions, in terms of whether it's cased or uncased. We have some multilingual and some, like for example, Portuguese and German specific versions. So I think we're just under 100 different types of embeddings that come with the library. One of the things Spark NLP does for you is it takes care of downloading the models, caching them, if you need to, distributing them over cluster, optimizing memory and performance use. So all of that basically happens for you in the background, which is something you do not have to worry about at all. Another thing that Spark NLP does is support multiple languages. And as I mentioned, there are models for different types of models for 46 languages overall. And one of the other things the library can do is detect the language of text. And this is one of the models that does this, that differentiates between 20 languages. Also another model that differentiates between 7 languages, and really up to you depending on what kind of text you have. There are 2 nice things about this model. First of all, as you can see, it's between 97 and 99% accuracy. So it's a highly, highly accurate model for text longer than 140 characters. Okay, and that's important because sometimes you have very short text you really just cannot tell. So if you have, for example, just the text hello, and you have a question of whether this is British English or American English, you just cannot tell. And this happens in some language, like Czech versus Slovak, Romanian versus Italian, even Italian versus Spanish sometimes. The other nice thing about this model, it's under 5 megabytes in memory, right? Which means that it's small, it's efficient, it's fast to load, and fast to use. Other things that we do, and I said that the library has more than 250 models overall, so there are quite a few tasks. One of the most useful ones where we see people using it in practice is spell checking and spell correction. And earlier this year, we released a new model, a new state-of-the-art model for automated spell correction in English. And as you can see here towards the bottom of the slide, one of the nice things it can do is it can make corrections based on context. So for example, you have 3 sentences here. I will call my sister. Due to bad weather, we had to move to a different site. Or we traveled to 3 sites in the summer. So in this case, you have the token, SITER, which, by the way, is a word in English. So if you're using dictionary-based spell checking, you might actually leave it as correct in all cases. But here you find the algorithm correctly finds that it is misspelled, and it corrects the exact same word in 3 different ways depending on context. As you can see, this includes dealing with things like singular versus plural, and there are other grammatical rules that it knows how to do. So some conjugations, even sometimes replacing things with proper nouns like people's names or place names. On the Holbrook benchmark, which is kind of the best academic benchmark we found for spell checking, this model had a word error rate of just over 8%, comparing, for example, with just over 20% for the jump spell open source library in Python. So if you're looking to do spell checking and automated spelling correction, that's a nice option that's available out of the box. And there are quite a few other places where we worry about accuracy. So in general, the race after accuracy never ends, because when you say that you're doing state-of-the-art accuracy, really what it means is that every time someone publishes a new paper, you're behind again, right? So a lot of what we do, and the reason we release software so quickly every 2 weeks, is because a lot of the work is keep reading the new papers, keep looking at people who claim to improve the state of the art, and keep re-implementing things. So this year we have re-implemented document classification, we have re-implemented sentiment analysis, we've re-implemented sentence boundary detection, we have re-implemented spell checking, and I definitely expect that we need to do this next year as well as accuracy, as the achievable accuracy improves. And our main promise to you and the community in the industry is that we will always keep you at the state of the art, right? So we'll keep replacing the algorithms, implementations, transformers, whatever may be the case. So other than accuracy, the next thing we worry about is speed, performance. And when we started Spark NLP, life was simpler in the sense that the reason Spark NLP was very fast to begin with was because it is written in Scala. It was designed for Spark. It runs natively on the Spark data frames without copying any data. So for example, if you compare it to using, say, Spacey or NLTK or even Stanford NLP, a lot of the time you would spend there was really just copying data from your JVM process where Spark was running to your Python process and back. Even with Stanford, you had to copy data in memory between different data structures. And there was really a lot of time you'd spend just either copying data in memory or serializing and deserializing data. And Spark NLP completely avoided that. And we've done a lot of work on profiling, optimization, a lot of work with Databricks to make sure the library ran extremely fast on a single machine as well as on a cluster. But that was in 2017, and we're at the end of 2020, and the requirements have changed. So here's what we focus on now. One thing that's super important that we show on this slide is tuning the library for really the newest hardware platforms. So Spark NLP has optimized builds both for NVIDIA GPUs, as well as the latest Intel chips. So Intel Cascade Lake, for example, which is what Amazon just announced yesterday that they're adding as a new type of GPU on AWS. And because those Intel chips have specific deep learning instructions, we've done work with NVIDIA and with Intel to create optimized builds of Spark NLP that utilize those chips. And here's one benchmark we ran a few months ago on AWS. The benchmark here was to train an M90 recognizer in French for 80 epochs, basically to reach the same level of accuracy. And in this case, as you can see, Intel actually outperformed NVIDIA, both in terms of speed and by far in terms of cost for this use case. But these are basically the benchmarks we run, and we make sure that really, whatever your environment is, if you use Spark NLP, you'll be able to make the most of the hardware that you have. Another important consideration with modern NLP algorithms and pipelines is using transformers and using embeddings. Transformers and embeddings are slow. They're complex, they're multi-layered, they take a lot of memory to run. And other than using GPUs and using strong computers with a lot of memory, there are also some optimizations you can do on the software side. And really the main use here is basically that we've done them. So with Spark NLP 2.6 that came out about 2 months ago, we've improved memory consumption by 30%. And this is on the same transformers, right? Not by making the transformer smaller. And we improve performance by more than 70%, basically with dynamic shapes, meaning that we don't actually load the whole thing, and we use custom data structures in memory to make sure that inference runs 70% faster than before. So as I mentioned, all of this happens behind the scene. You do not need a separate library to access embeddings on transformers. You do not need to optimize them for yourself. You do not need to cache them or distribute them or optimize them. We do all of that for you. Another important thing to consider when you're using embeddings on transformers is really sometimes just using smaller ones. And there's been a lot of work in the past 2 years on distilling transformers and making them smaller. So what we do is we just give you all of these options out of the box. So we have large BERT and regular BERT, but we also have tiny BERT, mini BERT, small BERT, medium BERT, and with different dimensions. So really you can choose your own. Okay, so for example, as you can see here, tiny BERT is 24 times smaller and 28 times faster than the regular BERT base, which is significant. The trade-off, of course, is how much you lose on accuracy. But in some cases, for example, in some document classification use cases, you may only lose 1 or 2 points of accuracy. Okay, so it's going to be a really good trade-off to come and say, no, let's actually go with mini BERT or tiny BERT, because then instead of needing to load a 2 GB model into memory, I only need to load a 50 MB model. So I can run on small devices. Just the time it takes to load the thing at startup, instead of being 2 minutes, it's more like 5 seconds, right? And accuracy is almost the same. So we give you this option so that you can make those trade-offs within your own use case. Another way to achieve a higher speed is to scale. And Spark NLP still is the only open source natural language processing library that's natively distributed and that can take advantage of a cluster. It is based on Apache Spark, right? Hence the name. Every Spark NLP library is a Spark ML library. So one of the cool things that Spark NLP does in its design, it uses the regular Spark ML pipeline class. Okay, this also means that you can unify your pipeline, so you can have a single Spark ML pipeline that loads data, say from S3 or HDFS, does some transformation, then does some NLP tasks, right, on the text that's within the data. But then within the same pipeline trains, say a random forest, right, does some grid search for hyperparameter optimization and writes this back to a cluster. You can do all of this within the same pipeline. You can send it together to the Spark execution planner. And really, scaling is the area where we really take advantage of Apache Spark, because distributed computing is hard. And there are things like, how do you do execution planning? How do you do caching? How do you minimize shuffling and the amount of data on the network, right, to use the bandwidth most effectively? And these are really the things that the Spark community is focused on and put thousands of man-years on over the past decade. And we've just done the optimization to make sure we take advantage of all of that. And of course, looking at the caveats here, your speed up, meaning how much faster you're going to be when you add machines, it will depend on what you do, right? So if you're doing inference on pre-trained models, you should expect almost linear speed up. But for example, if you're training deep learning models like say CNN that is by nature more iterative, you get sublinear speed up because there's more data to transfer over the network between the different machines. On top of that, if you have large clusters, so if you have 200, 500, 2,000 machines, then definitely knowing how you configure and manage large Spark clusters is important. Here's just one example of what you can expect from a single node, and then when you scale. So here what we did, we took the Amazon full reviews data sets, so 15 million sentences, 255 million tokens, and we trained. We ran a pipeline, so we split into sentences, we tokenize, we calculate embeddings, and we run name entity recognition. Okay, and as you can see, on tokenization, basically we had super linear speed up, right? So we go to 10 nodes, but we're more than 10 times faster, because tokenization is trivially parallelizable. Know that on a single node, know that 340,000 words per second is low. On name entity recognition, we get a really nice speed up, right, from 38,000 words per second to 136,000, right? But it's sublinear, right? So it's less than a 10x growth, right? Because the entity recognition is a heavy deep learning algorithm. So basically what I'm saying is, depending on your own use case and your own pipeline, you'll need to run the test and see how scaling works for you. Okay, so that's where Spark NLP is today. And that's what what people expect and where the state of the art is in terms of accuracy, in terms of speed, and in terms of scale. And of course, our goal is to keep moving with that, right? So every year we give more to the community and the industry, and of course the state of the art rises as it should, and our goal is to keep you up with that. But one other thing we do is trying to make all of this easier to use, because a lot of the challenge that people have with NLP is really just even keeping up with all the new things that are happening, all the new capabilities, all the new optimizations, all the new algorithms. And one of the things we want to do is making sure that really anyone can use this and anyone can just make the most of it and build their own projects. So for that, one of the things we've done this year is we've introduced a new library, which is the NLU library, which is the next thing that I'd like to share with you here. So NLU is a Python library. If you want to use it, all you need to do is pip install NLU, and you're done. And it has those three very simple design goals. We want powerful one-liners, and really the design was to get to a point where almost anything you should be able to do in one line of code, right? And yes, of course, you can use multiple lines if you want to dive deep and change configurations, right, and do things that are harder. But most tasks you should be able to do with just one line. We want to very easily integrate with the rest of the Python ecosystems, right? Especially pandas data frames, right, and other kind of data frame formats. So that, for example, you get some text, or you just want to calculate embeddings and then move it to PyTorch or something else, or you got some text, you want to run spell checking or get named entities, and then send it to some relational database or other, you build some other recommender system, you can just do that. And we want to make it very easy to integrate with the rest of the Python ecosystem. And of course, we want to keep it open source, Apache license, so that anyone can use it anywhere. So to show you Spark NLU, I'm just going to go through a few examples. But for the first examples, here's how you run spell checking. So pip install NLU, you import NLU, and then it's basically NLU has two functions you need to know about, which are load and predict. NLU.load spell, and spell is the term for US English spell checking. So we load the spell checking models, .predict. In this case, we just give it a string. I like peanut butter and jelly. What you get back is a pandas data frame. Okay, and here's the data frame printed. You have the tokens, and then you have the checked or the corrected tokens. And in this case, as you can see, the words like, peanut, butter, and jelly, all of them were corrected by the spell checker. Okay, so that's really all you need to do in order to correct the spelling of a sentence. What happens in the background is this: load. We tell it, oh, I need spell checking. What it would do is it would find everything that's involved in the spell checking pipeline, right? This does tokenization, spell checking, and that's it in this case. It would download either from the web, or if it's available locally from the internet, or if available locally from local cache. It would load the models. Okay, so there are, for example, spell checking models, there are deep learning networks, there are embeddings that need to be used. Right? Whatever needs to be used will be loaded into memory, configured into a pipeline, and then ready to run. When you call predict, we just take the string, run inference on it, and give you the results as a pandas data frame. Okay, so that's really all you need to know here. Here's another example where what we want to do is take text, tokenize it, and calculate parts of speech, dependencies, and the labels for those dependencies. So basically the grammatical dependency tree of a sentence. So NLU.load dep. Dep is the shorthand for dependency parsing in English. .predict, and we have the sentence is a pandas data frame, and you can see, for example, that tree structure, the words tree and structure are nouns. The label dependency, so tree is flat, but structural is dependent on the word tree. Okay, you can see the word represent is a verb, and so on. Here's another example: emotion detection, NLU.load emotion, .predict I love NLU. And what you get here is a data frame that tells you, first of all, it gives you the sentence embeddings, because this model uses universal sentence embeddings in the backend. tells you the main category of this sentence is joy here on the right, but it gives you the results for this sentence being either a surprise, sentence, joy, or fear emotion. Okay, so that's it. Here's another example, sentiment analysis. NLU.load sentiment.predict. I hate this guy, Semi. You get the result. The sentiment is negative, and the confidence is, in this case, 0.57. Let's look at some other examples. Language detection is one of the other things that the library can do. So NLU.load lang.predict. And here, what we do, we don't give it a single string. We give it an array of 2 strings, which is one of the things that predict can accept. One of those strings is in English. The other
Hi everyone. So I guess our guest has had some technical issues, so he won't be joining us to finish his talk. It's really unfortunate, but we will be back soon with him again or another guest. So I hope everyone enjoyed whatever they heard, and I wish everyone a good night and a great week ahead. Thank you.